All right, so my talk is called Carving Text at its Joints, a New Perspective on Writing in Computers. So let's just jump right in. So this is kind of an outline of the talk, but I'll just skip over this because we'll see it again. So introduction. So everything is human-made in this, I just want to clarify. So to begin with, computer users rightfully expect to be able to input, view, transform, and edit text in their own language, in their own writing system. And it's 2025, so software must reflect that fact. English only, ASCII only, fixed with fonts, they're just not going to cut it anymore. So, what's the problem with that? Writing is hard. Human writing is quite difficult. We have come quite a long way over the past 3 decades, but much work remains. The modern tech stack, it can almost get us there, but there are major open problems, by my estimation anyway. So, the thing is, this extreme complexity really economically disincentivizes minority or minoritized writing system support, because those often work out to be the most complicated, not the least of reason because there's just less experience with them, less of corpora and so forth. And that can further contribute to their marginalization. If you can't text, you can't email in your writing system, in this day and age, it is in a quite marginal position. So I think as a matter of linguistic justice, there is a particular urgency, I think, to the subject that I want to talk about today. So, what is my goal here? I've kind of ripped off Milton. My goal is to justify the ways of linguists to computer scientists with his own characteristic humility. So I want to argue that the way that we've treated text heretofore is wrong. And to understand why, we need to historicize the basis of how the status quo came to be. I think that the apparent complexity is largely extrinsic, not entirely, but largely. And it's really the result of bad, or in many cases, no abstractions. What happens is that the particulars of every writing system sort of intrude into every application because there is no abstraction. And the correctness kind of appears locked in this internal struggle. But I come bearing and offering a piece. Tractable and correct text handling is possible if we are willing to radically rethink what computer text is. So, let's do that. And my quote is or my title is a reference to the Phaedrus, Platonic dialogue that deals with the origin of writing. Of course, in it, Socrates says that writing is the worst invention in history, so maybe it's a bad reference. But I think what we need is a proper philosophical account of what computer text is, which is a term that I've been quite insistent on. So I have 2 solutions. One is an alternative style of text encoding, and another is a model of programmable digital typography, or computer typography, and I'll get to that, both of those in due time. So I'm guided here by kind of 3 aphorisms. There's no such thing as plain text, fonts are programs or functions, and writing is an interface, writing systems are its implementations. So, next section. Here's just some definitions that might be helpful. So a grapheme, that's a tendentious category in graphematics, which is kind of a weird field, but basically it's kind of the smallest semantically meaningful unit of writing or text. A logogram is a symbol which denotes a word or root instead of a sound or syllable. A quadrat, this is a Mayanist and Egyptological term, but you'll see what it means in a second, but just bear the word in mind. And a diacritic, I'm sure many of you know this word, but it's just something that modifies kind of a base glyph. All right, so I'm really interested in the Maya script in particular. So I want to introduce this briefly just so we have a common ground. It was developed in about the 3rd century BC. It is one of only 4 independent inventions of writing that we know of, the other 3 being cuneiform, Egyptian, and Chinese. That is, linguists disagree about this, but those 4 are unambiguously known to be independent, more or less. And it was used to write the classical Maya language. It was suppressed by the Spanish colonial authorities in the 16th century, and then thereafter forgotten. Now, I put this slide up just because I wanted to show you a picture. I think this is one of the most amazing portraits of all time. So this guy was a Soviet linguist, Yuri Konorizov. He was the one who deciphered the Maya script in the mid 20th century, but it is still not fully understood, and we will see that in a second. So here's just some more examples of Maya. The Maya script is this part right here and right here. The rest are more illustrations of what's happening in the text. This is another Maya text. This is printed. This is in one of 4 known Maya codices. This is the so-called Dresden Codex. Now, why care about a dead writing system? It's an interest of mine, but why should you care? Well, I have 4 reasons. So there is periodic interest in reviving the script for contemporary Mayan languages, which have millions of speakers. Maya is complex. It is highly complex, and it's a good stress test for software. By the same token, it's very different, and it challenges faulty assumptions we have about text. But also, I think it's just inherently interesting. So let's actually look concretely at some Maya text. So this is a glyph, it is a collection of glyphs. It says he or she, there's not gendered pronouns, sat. But there's more here that meets the eye. So Maya text is organized into blocks called quadrats. I used that term before. But note that what you are seeing on the screen is not a grapheme. So, guess in your head about how many components you think this has. And I'm going to spoil the answer here in a second. The answer is 4. So I've color-coded the different ones. So let's look at what that means. So I put a transliteration up there, or I really should call that transcription, because it's giving an account of what these individual glyphs are. But you'll notice in the pronunciation, it's not chumulaha, and note that the J is pronounced like as in Spanish. It's something like chumlah. Written Maya has a quite complex relationship with its actual vocalization. Some glyphs functions as logograms, such as chum, which is like a logogram for sit. Mu, this little blue character, is a phonetic complement. So it's not directly pronounced. It kind of gives a hint to pronunciation. It's giving a hint that the chum ends in a bilabial nasal sound, an M. But Maya is actually mostly syllabic, and this was Konorazov's great insight. If you're interested in the decipherment of Maya, I can tell you a little bit more about it after the talk. But Maya can't easily represent closed syllables, so its solution is to sort of fake it. You write 2 syllables that have the same vowel, and you ignore the second one. And that workaround is quite common cross-linguistically. We see something somewhat similar in Linear B, which was used to write Mycenaean Greek. Maya layout is ridiculously complex, as you can see here. This mu character, this phonetic complement, is infixed. So there is a full-size version of that glyph, but here it's being superimposed, shrunk and superimposed over the thing that it's modifying. Maya quadrats that I have seen can have as many as 6 independent components, and these aren't diacritics, but those exist too. At least I'm aware of one diacritic in the Maya script. Quadrats also frequently include numbers, and we'll see examples of that. So this next section I want to call 3 myths that computer scientists believe about text. What I want to say is that computer text, it really is its own modality of writing. It's a unique phenomenon. And the reason why that is because it just has modalities, modes of use, modes of interaction that don't have any analog in other forms of writing. Like you don't backspace on a well, you kind of can on a typewriter, but you don't have arbitrary insertions and manipulations like on a typewriter. So there are questions that have to be answered. So how should backspace work? Should the cursor, in the case of Maya, travel inside a quadrat? It seems like it should, because if it couldn't, imagine if you could only delete English at the granularity of a word. That would be very annoying. But there's no obvious answers here. We really are living in a Latin world. Maya also just had, we can't ask a Mayan how it should work, or an ancient Mayan, I should say, because the system is dormant, and it also had no print tradition. So the bottom line, there may be no single fact of the matter about how these interactions should work. And there's more familiar examples like, backspace. Does that delete a whole letter or part of a letter? In languages that have very complex stacking diacritics, it might be quite annoying for the same reason as Maya. Myth number 2, there are no new writing systems. So here's just some counterexamples. These are all writing systems that developed past 150 years, starting with Cherokee, which some of you may be aware of who are American, and ending with this last one I'd like to talk a little bit about just briefly, that a colleague of mine and friend introduced me to about a year ago exactly. This is an emerging writing system that's kind of designed to give a common orthography to many related languages in southern Africa called Ditema Tsadinoko. There's another name for it that is quite hard to pronounce for me, so I will not attempt it. Last myth. Writing is a linear sequence of symbols. And so I won't read it for you, but I find this quote from Giannis Haralambous and Martin Durst quite helpful as an example, or as a characterization of this phenomenon. So let's look at some examples. Nastaliq is a variant of Arabic, and I just want to point out, it is difficult. This is not how it's normally written. So it's not normally written in this pinwheel shape. These are, individual lines right here. But the main conceit is that words are written kind of at a diagonal, and they sort of overlap diagonally. But what's crucial here is that from a Western typographical perspective, there are as many ligatures as there are words in the Urdu language or whatever language it is being written in. This is a poem by the Persian poet Omar Khayyam that you see. Bidirectional text, everybody knows about Hebrew and Arabic, no surprise there. Though I will note, for people who don't speak either of those languages, myself included, European Arabic numerals, it's kind of a funny thing, they were kind of borrowed back into the modern Arabic script. They are written left to right still. So pretty much all long Hebrew Arabic text which uses Western numerals is bidirectional, as is embedded Latin text is of course written left to right too. Now let's talk about vertical text. What you see on the screen is a bilingual sign in Chinese and Manchu from the Forbidden City in Beijing. And you will notice the Chinese, it is written vertically, but the glyphs are not rotated. They're written in the same way they would be written if they were written horizontally. Manchu, on the other hand, is basically a 45 degree, 90 degree rotated Syriac, basically. That is his ultimate origin, although it's diverged quite a lot. And vertical writing really doesn't refer to one phenomenon. As I talk about here, you can be written in columns left to right, right to left, and so forth. And how does horizontal text interact? So the traditional Mongolian alphabet is written only vertically. The Mongolian government plans to reintroduce the script. Software is really not ready, so I think this just kind of highlights the urgency of vertical script handling. So, all right, we've seemed like we have left to right to left, top to bottom. Surely no one has written bottom to top, but you would be mistaken if you thought that. The Ogham script, Ogham, was used to write a early form of the Irish language, and it is written bottom to top, typically, in epigraphic in epigraphy. So here's another example. This is a script probably haven't seen before unless you're into this kind of stuff. These are Anatolian hieroglyphs. They're used typically to write Luwian or Luwian. It's typically written in a boustrophedon order, so that is to say alternating lines of left to right to left, and the human and animal-shaped glyphs face the start of the line. However, within a line, glyphs may vertically stack. So, it's quite complex. All right, so how is Maya text read? Horizontally or vertically? And the answer is yes. It is in both. It is typically, though not always, written in a zigzag pattern, and then, if there's an odd number of columns, the last is vertically. And consider that the quadrant also has an internal reading order. Egyptian, everybody knows Egyptian. It is quite, well, you've seen it before, to say. Left to right to left, just like Luwian, or Anatolian rather. It is also organized into hieroglyphs. And I will note something interesting about Egyptology is that Egyptian typography is quite common, or typesetting, I should say, is quite commonplace. That's quite routine, because hieratic, and I'm going to make some Egyptologists groan by saying this, but it's a kind of cursive hieroglyphs, so they're often transcribed into the normal ones. And this cartouche right here is a name you probably recognize. It is Cleopatra, although not the famous one, I think. I think this is Cleopatra II. The famous one is the 7th. And then I'll just mention here briefly math, music notation. These kind of get at the boundaries of what text is. Do these count as text? I'm not sure, but I think they're just worth mentioning. So in summary, even writing direction is far more complex than we might imagine. Seemingly every possibility has been instantiated somewhere, and when we consider multi-directional text, the space just explodes. I think what's important is that complex scripts seem to have a global and local writing direction. It almost has this sort of fractal character to it. And the physical order, especially in Maya and Egyptian and Anatolian, really just doesn't neatly correspond to the kind of logical reading order. So, we're going to talk about Unicode now. So Unicode, it's had some major success. It really is universal. I gave a version of this spiel to someone at a previous conference. They said, okay, yeah, but like, I remember the pre-Unicode days. So, it might be hubristic to criticize it, but I don't think any technology should be sacrosanct. So I want to offer some critiques of Unicode, but I'm going to duck for any flying tomatoes. So Unicode is about plain text. Formatting explicitly outside of its purview. And what do we mean by that? Well, what does the Unicode specification say? It says, plain text is the underlying content stream to which formatting can be applied. It must contain enough information to permit the text to be rendered legibly and nothing more. And I want to deconstruct this category. So, computers, I think, really have a dual ancestry. There's this kind of highbrow, stuff of Frege, Peirce, Gödel, Turing, Church, von Neumann, Ada Lovelace. But there's also the more banal, the typewriters, teletypes, Baldo codes, and that latter category is really where we inherit the kind of typographical restrictions that I, anyway, associate with computers. So I want to share a sort of fable with you, and this is a story from the history of English. So this is a Middle English poem from the 14th century. It's called Piers Plowman, or The Vision of Piers Plowman, by the poet William Langland. And I want you to look closely at this Middle English text, and I have a modern English translation for you here. So see if you notice anything. And what you'll notice is that there's this strange character here that I've highlighted in red. Now, this is a letter called Thorn. It is adapted from the runic alphabet, which I'll show you an example of in just a moment, and it denotes the dental fricatives, the TH sounds. We're going to ignore eth for a second. You can ask me about it afterwards. It's still used, the Thorn is still used in modern Icelandic. So this is the most famous example of Anglo-Saxon runes. We're looking at Old English, not Middle English, and you'll note this is not the Latin alphabet. And you notice there are thorns right here at the bottom that I've highlighted. Now, notice also that they are written right to left, as was common in the runic alphabet. So thorn clearly isn't used to write English anymore. It seems quite useful. It can disambiguate ambiguities in our orthography. So what happened? Well, the answer is the printing press. Western printing began in continental Europe. Continental European languages do not use thorn. Thus, type imported did not either. So thorn fell out of use due to technological limitations. And by the way, when you see ye old shop or whatever, that Y is short for thorn. It's not pronounced ye, it's the old shop. But it's also not that because it's fake. But anyway. So I want to talk about Nastaliq for a moment, and I have this quote from a Urdu-speaking technologist named Zarek Ahmed, and he said, all Urdu software is broken because the underlying data is broken. Now, Nastaliq really, really needs fine-grained layout control to be displayed correctly. Unicode shunts this into formatting, but the problem is Nastaliq is just kind of broken. And the thing is, it's not just about aesthetics, it's about correctness. So I also want to briefly just touch on the Han unification here. I don't really want to hold court on the subject. It's outside of my wheelhouse, but I'll just say I think the lack of formatting is a major problem. This is a problem that could have been solved that just isn't, even with unification. So let's look at something a little closer to home. We're computer scientists, not linguists. So this is Algol 60. This is a screenshot from the original Algol 60 report, and I want you to notice the syntax here. So the bolding, that is not syntax highlighting. That is part of the syntax itself. Algol relied on that bolding to distinguish keywords from identifiers. And the thing I think that's interesting is that its creators, they made it for print. They weren't constrained by what computers can do. I'll just briefly mention APL. Similar sort of thing happened in the 1990s when Kenneth Iverson and Roger Hui came to design the J language. They dumped the APL character set for ASCII, which in my opinion is quite a bit of a downgrade. So there's a lesson here. For 15th century printers, Thor was not plain text. You can read English without it, as we clearly can today. But by contrast, for the Algol 60 committee, bolding kind of was plain text. Algol 60 doesn't work without it. So many things that Unicode deem formatting are needed for correct display. And I think the consequence is that plain text, it's indexed to a time and place. It is not a transhistorical category. So next thing about Unicode, I'll talk about legacy encodings. I'm just going to mention this briefly. Many of these legacy encodings are so utterly irrelevant to the present day now, but we are paying the cost for them and will pay for the cost of them in perpetuity, just by structure of Unicode, because it's what causes the multiple normal forms. The last thing I want to talk about is what I call the necessity of structure. So Unicode is kind of nominally flat and unstructured, but that's not actually true. Okay, 10 minutes? Okay. So simpler, yes, but simpler for whom? Can we cut this Gordian knot and simply accept structure? So here's an example of emojis, but emojis are quite structured. Here's an Egyptian of layout control, which requires actually a context-free grammar to parse. So, okay, Egyptian and emoji are both structured, but in very different ways. Can't we just solve this problem once? And I won't go into the XML stuff, but I want to talk about now my solution to this. So I want to sketch a new kind of encoding, and it's a scheme I call telecode. If we were to do Unicode over again, how would we? It's very difficult to separate these different spheres of interest, can't always be neatly separated. Everybody wants something different, so let's just kind of do everything. So this data structure is a sequence of ordered labeled n-ary trees where you have base characters, tags, and attributes. Tags introduce and delimit tree nodes, or branch nodes, I should say, and base characters would be leaf nodes, and attributes modify both of those. So this is kind of an example of how you might encode this cartouche, where you can see the red arrow shows the order, like the byte level order of the code words. So you start with an open cartouche, open stack, those hieroglyphs, end, vertical attribute, and so forth. So crucially, telecode is a fully decomposed representation of text. Everything, including diacritics, including case, is accomplished through attributes. It is easily segmentable because each grapheme, the number of graphemes is just the number of base characters, basically. And I mean grapheme in the less tendentious computer scientist sense, something like a unit of interactivity. It is self-documenting because the properties of a character can be derived from the encoding directly because these different categories are encoded in different encoding spaces. I want to briefly talk about my self-normalizing scheme, and then I'm going to move on to the typography. Unicode, so let's see. One thing that's really difficult about normalization is order of attributes. Because, so like the circumflex and the ogonek, it doesn't matter which order you encode the diacritic because they're orthogonal. But with an acute accent, if they're stacking, it does matter because that has typographical implications. So the solution I came up with is that you encode the class, the kind of set, as a offset in a sequence of attributes such that it is impossible to store an unordered sequence. So I'm going to skip this page actually, and I'm going to skip that page because I want to talk about fonts as programs. OpenType, how am I doing on time? Okay. OpenType, standard outline-based font technology. Letter forms, they're just stored as outlines. Here's an example on the right. Uses these shaping models, but they're sometimes inadequate. It tries to sort of, it tries to account for all complex behavior languages ahead of time. Difficult parts of text rendering: hinting, which is basically fixing up outlines at low resolutions. Kerning, I think many of you know what kerning is, but I have an example. Shaping, I have an example of poorly shaped and well shaped at the bottom here. So my claim: fonts are functions from abstract text to concrete visual forms. If we do this right, then all these modes of use can kind of fall out from a much more general mechanism. And for systems that have this sort of unbounded number of letter forms, I really don't see another option. I'm going to skip this so I can get to the other thing. I'm sure many of you know about metafont. I'll just say briefly that metafont, it doesn't have the generality that I'm looking for here. So let's talk about my approach to this problem. It is a typography engine I've called Dubsar after a Sumerian word, and you will see those cuneiform characters typeset with the software at the top. It is merely a program in the language of the bytecode, and the code is constructed such that it kind of presents a uniform interface to all writing systems. I'm going to go over this briefly. This is quite vague because this system is in daily flux, but the basic idea is that the runtime traverses the set of trees or the sequence of trees in a depth first order, and when it encounters something I call a scribeam, something that is kind of a unit of drawing, it dispatches to a handler, which is written in this bytecode. And the bytecode can sort of arbitrarily inspect the graphic state, the cursor, it can set the cursor state, we'll talk about that in a second. It can arbitrarily inspect the input text, it can look ahead, it can look forward in some cases. And it's a stack-based machine, purely stack-based, unlike the JVM or WASM, and is statically type-safe. So it's mostly designed for telecode, this system that I've described, but you could make a font that ingested Unicode. It is stroke-based rather than outline-based. Glyphs, like Metafont, are the envelope of a virtual nib stroked along a path that can be controlled programmatically. This format turns out to be massively more compact. I have seen some quite compelling numbers in this regard, especially for large character sets like CJK. And it's arguably more semantic. Hinting, in particular, is largely obviated by the need for stroke-based because you just sort of know where the line is. You're not sort of reconstructing it. But even so, rendering PPI is a runtime parameter. It can be inspected by the code. When glyphs are drawn in the graphic state, they are tagged, and handlers can sort of inspect and modify the graphical render state at any time, up to like deleting, adding any of these individual elements, and they can tell which component was drawn for which element in the input stream. And this actually turns out to be sufficient to implement kerning, shaping, text substitution, and so forth. Also, each scribeam handler is responsible for returning the state of the next cursor, and it can kind of turn, shrink, curve to sort of fit these complex script layout. I do block level rendering. This is a little bit controversial. But the reason why I do this is because justification is actually kind of specific to a writing system. In particular, the Arabic Kashida system where letters and not white space are stretched. And it turns out this is actually not that wasteful. The Knuth-Plass algorithm, which is what's used in tech, compiles to about 7 kilobytes, and I suspect that that is much larger than it needs to be. It could probably be half that, I believe. But even if not, it's made up elsewhere. Here's a case study on Latin. This is an adaptation of Hershey fonts. These are early stroke-based fonts. I'm still a journeyman font designer myself. But important thing to note, there is no manual kerning. So each of the subroutine or the handler for each of these glyphs, when it is written, it's looking into its context and placing itself. So you can see right here, we have this a little bit over-kerned, I might say, E, and this T is a little bit under-kerned. But there's no kerning tables. And this, for large character sets, this is hugely beneficial because there's a combinatorial blow-up. Just, you think about every pair of letters, right? And then finally, we'll talk about Maya. my favorite subject, of course. This is a very, very work-in-progress font, but you can see here, this is a typographic rendering of that lintel that I showed you at the very beginning. And I've included transcriptions, transliterations, translations. These are not my own. They're taken from a very helpful website, mesoweb.com, very good for Mesoamerican resources. And you can see here the extent to which the Maya script is really not fully understood because there are words that are just left untransliterated. Also, I don't know if there's by any chance anybody who speaks Georgian, but this sound is the same as the k in Georgian, just side note. Anyway, this took a lot of work. I'll just say that. This is a long bit of work, and it's still very much a work in progress. So, onward. Because we are onward. Where does this leave us? Can Unicode really be displaced? Are font designers going to become programmers? Well, look, I'm not delusional about this anyway. I don't think that I'm going to replace Unicode, but I do think that thinking about text encoding can maybe inform better text data structures in programming languages, operating systems. My strongest claim would be that I think that operating on Unicode directly is pretty much always mistaken, I think. I think, as an interchange format, so be it. But there are applications where interoperability doesn't really matter, like embedded programming, and maybe a different encoding would be perfectly fine in that circumstance. Lots of old video games didn't use ASCII, for example. They would use their own encoding set because nobody's going to read it. It doesn't matter. But I'm forging ahead with it in my own work, in operating system and PL stuff that I have hobby projects or whatever. But I'm much more sanguine on programmable typography. I do think that this is something that can work. I am working on a public release of this software system, and the last slide will have a link to that if you want to take a picture of it. I think this is possible, and I think this is borne out by recent developments in the Harfbuzz, Shaper, and so forth. So I think there is an appetite for that. So with that, I will leave you with this other quote from the Phaedrus and questions, if there are any.
Excellent. That's perfectly timed, and we do have time for questions. People, please use the microphone so they can be recorded and transmitted.
Hi.
Hello.
So, yeah, I guess I have two questions.
Please.
My first one is about, let me know if you've already addressed this. So in Chinese especially, there tends to be recursion in characters because you have you only have a set of 8 or so basic strokes, and they compose.
Right.
And then these compose. Yeah. So does this system, does this handle this well?
Yes, it definitely could. I will say I really don't know much about Chinese. I actually need someone. I need to work with someone who does because okay. Well, there you go. I'm very ignorant about it. So if you want to please, any Chinese speakers, please contact me. So very helpful.
My second thing, I guess, is it's not so much a question. I'm very, very excited to see another historical linguistics interested guy.
Oh well, thank you.
And
thank
so
you.
I'm wondering if you've ever thought of, apart from typography, if you've thought of applying historical linguistics to how programming paradigms evolve and that sort of thing, idioms and conventions.
That's a really good question, and kind of. I won't. Maybe I'll talk to you after that. But it's a very good question, and yes, I'll say yes.
All right. We should talk.
Yes, let's talk afterwards.
All right.
Hi there, really cool work, as
Thank you.
Everybody's going to say. So something you didn't touch much on about when you were talking about plain text, but I was reminded of when you talked about case, is the presence of localization and plain text and how those interact. For instance, what is uppercase dotted I? It depends on if you're speaking Turkish.
Yes, exactly.
What is, and also word ending things. You talked about normalization and in Arabic and Greek, in Hebrew and you have word ending forms, which are those normalization? What is a word ending?
Yeah.
So, you already wanted to complicate the notion of plain text, which is great. do you see, this is sort of ill-formed, but like, how do you see localization and language dependence playing into these normalization notions?
I'll just say the Turkish eye problem has vexed me because it's
You and everyone else.
Many people in the paper. I didn't talk about this in this talk. It's kind of morbid. I feel bad about laughing about this, but there's actually a case where mishandling that led to someone being murdered.
I recently shared this article somewhere.
Yes. So it is actually quite significant. I don't have a good answer for that. This is a very vexing question to me, I'll just say. And inchoately, I would say some kind of metadata tagging has to be the answer here, basically.
All right, cool. Thank you.
You're welcome.
Hey, Kevin, really cool talk.
Thank you.
I have a more programming question. So,
Please.
So Unicode, of course, has like all sorts of problems with, say, like indexing. Like they're not all like constant width, and lots of people would like to believe that an array of characters is literally just something you could jump into the middle of. So anyway, so now I'm thinking about telecode. Okay, so
Right.
Can you tell me a little about programming with telecode, and what actually is the data structure that I interact with if I'm writing a program that's manipulating telecode?
Yeah, so I just for time's sake, I skipped over the slide where I talked about this, but two things. The data model is quite similar to XML. So you're talking about regular trees. That's what telecode is basically. It is, like I said, quite similar to XML. For indexing into Grapheme is similar in complexity to indexing UTF-8 by code point, if that makes sense. And that was an intentional design choice because a Grapheme is always started by a base character, always.
So there is a way of jumping to the beginning of something.
Yes, you can jump to the beginning. The encoding that I'm working with is self-synchronizing, and the way UTF-8 is UTF-8 OID. The other thing I'll say is that I envision for this, the analog of regular expressions would be like regular tree languages, basically. So like XML schemata, very similar. And I didn't have a chance to talk about it, but they have a lot of this, as I'm sure you know, similar closure decidability properties. So it actually works out to be a quite nice analog. And this came out of experience with XML stuff, so.
Yeah, good.
You're welcome.
Fantastic. Yeah.
Hi, thanks. First, I would like to just mention, if you're not familiar, Ramzi Nasser's Arabic programming language.
I do know about this, yes.
And really the question, my question though is about, with Dubsar, like, how does it deal with more graphic properties? Are there things like stroke width or like, virtual, stylus, medium, that sort of thing?
Great question. So pins, which I borrowed heavily from the Metafont model, you can change the width, you can change the orientation, you can change the shape of the nib, so it's like an ellipse. It can be an ellipse that's changed in orientation. It can change dynamically, which Metafont actually can't do. So that's basically the idea here. Yeah. So,
Great.
Thank you.
I'd like to clarify, I have no experience myself with Han characters as a person who writes them, but maybe if you have eyes and you look at Chinese text on a screen, you'll see that sometimes the fonts don't match because the people who design the fonts don't have full coverage. Do you see this as sort of a fundamental issue with like Unicode that your thing would fix, or do you think this is sort of more of a font designers need to think really hard? Also welcome for people who do speak or write with languages that use Han characters to talk.
Sorry, so the question was, you're saying like font selection?
So like people who design fonts using Han characters often don't cover the full set of Han characters. So when you render them, it doesn't match visually.
I'll just say briefly, I'm very interested in generating Han characters from like Chinese, like ideograph description sequences. Okay. I just don't know enough about it to really intelligently comment.
That's okay, thank you.
But thank you. All right.
Hello. I'm curious, so suppose that your system is developed to technical completion.
Sure.
And the only thing that's left is for people to use it or adopt it. What costs do I pay as a programmer if I want to use your system? Presumably you would have to have some, in source code I type some strings and all of my existing tools will save that as UTF-8, so presumably there has to be a translation from source code to use your system, and then what else do I suffer in order to get the benefits? I'm curious about that.
I'll just say briefly, and I can tell you more afterwards, I would like to adapt kind of word processor, a kind of forgotten word processor paradigm for editing. It's very vague, but just in the interest of time, but talk to me afterwards, I can answer it more firmly.
Sure.
Let's all thank Kevin once again. You're here today, you're here tomorrow? You're around tomorrow? Are you around here tomorrow?
I'll be here tomorrow.
And Kevin will also be here tomorrow.